Alright, today we'll be making a basic part. A plate with 4 holes in it and some radius. It's a 8x8 plate, 7-inch center on the holes, 3/8 hole, 1/4 inch radius. Alright, first we start in design. We're going to create our sketch, and the plasma table works in a 2D dimension top down. We're going to select our plane to work in, and we got all our shapes and tools up here in the top toolbar. We're going to start with a rectangle. We're going to click. Don't have to click and drag, just click. You can drag don't hold the button down and drag around. You just click and move your mouse around. Um, Type in 8. Press tab to switch dimensions. You can switch between your X and Y. 8x8. Scroll out to give us more room. Now we'll plot our points for our 3/8 holes, which are 7-inch centers. So we'll go a 1/2 inch from either end. I'm going to click line construction just for reference so we can plot these points. Go a 1/2 inch from either side. Oops, I did not mean to do that. We need to be in the sketch tools. We're sketching our part. 0.5. Doesn't matter how you get these lines on here as long as they read up to 7-inch center holes. And we're going to make sure they're 90 degrees. As you can see on the screen, it will show your dimension, length, and your degree. It'll automatically fix to 90 degrees once it reaches. You can also set in your degree. So like say we want it at 120 degrees. It'll lock it at 120 and we can drag it to whatever length we want, like to the other side if we need be, or 5 inches. Again, we don't need that. We're going for a 90-degree angle. So we're just going to drag it across. Just click and move your mouse. You don't have to click and drag and hold the button down. Just click. Oops, that is not 90. It did not affix to it. Again, let's say, just type in 90. Bam, it'll stay that way. I'll go just drag it to the other side and click. Click. Here we go. Now we've got our 4 corners, our 4 points to put our holes. And turn off construction. We need to create a line that's toolpath for the toolpath. Click. 0.375 or 3/8 in decimal form. 0.375. 0.375. 0.375. There's also a shortcut for circle, which is C. You can click C repeatedly if you want. You can also right click and it'll show your last tool or shape that you used at the very top here. You can just click that as well. You can move these dimensions around. Let's say they're hard to look at and you're trying to get a good idea of what you're looking at. You can move them around. Move to a better location. You can also turn off dimensions if you're tired of looking at them. You're just trying to get a general idea of what it looks like now. Turn off like that in the sketch palette right here. It might be minimized. Be right here. Click the 2 arrows and we'll open it up. You can also minimize it that way right here in the options. You can also turn on grid, snap points if you're using like creating multiple lines in a certain way. Profile, it will make a highlighted idea or a profile of the object you made. Turn that back on. Points, again, these dots right here in the corners as well. Dimensions, showed you that. Constraints are these symbols. Not sure the exact, use of them. Might be useful in a certain type of process. Not for this one, honestly. Turn that off. And it's about as simple as it gets for using this for plasma cutting. Now we're going to create our corners. We're going to use a fillet. I'm going to click it. And we're going to click the 2 sides together. Keep a dimension. You can either put it in, or let's say you're just trying to make a decent look for a part. You drag the arrow in and out. We're just going to go 0.25. Do this to all four sides, 0.25, or just right click, repeat fillet, 0.25. Right click, repeat fillet, 0.25. All right, now we've created our part. Simple and easy. Now, oops. When you look around, scroll in and out with the mouse wheel. When you look around, you might notice these like little straight lines right here. And if you don't like looking at them, you can go to your tool tab up here, go to modify, and go to trim, or the shortcut is T, press T. Let's see, press T. Got our trim. Now the highlighted purple section is what's going to disappear. So you got to be careful about where you cut it. I have to scroll in to get a certain area. Trim. You can trim the construction lines if they're hard to look at. Don't matter. They don't bother me. Now let's say you're like trying to get out of here and you're like, oh, how do I lose the tool? Press escape or right click and cancel. Right there, which is escape. Oops. Cancel that, didn't mean that. Now we'll make the three-dimensional part for the toolpath to follow, even though we will only work in 2D. It needs a 3-dimension for some reason. You create an actual part for it. So we're going to right click, actually going to click on our part. It's going to highlight it, right click, extrude, and you can give it any dimension you want. You can give it 100 million inches or just 0.125. Doesn't matter, just needs a shape. And as you can see, we got a three-dimensional part here. I've set my texture to gold because I like the color yellow. Now we're going to go back to top. Now we're done creating our part and we've got a body for it. I'm going to go to manufacture. Make sure it is on fabrication. And you've got cutting. We're going to click setup here at the top. We're going to make sure it's within this. You're going to notice it's going to sit in the middle exactly. We want it to the bottom left corner because we want everything within these two dimensions. Click OK. It's going to pop you at an angle. You can go back to top view. In this top right hand corner, the three-dimensional cube. Let's say you accidentally click, the wrong thing. You go to the right. You can go to the top, these four arrows on the sides. We'll click the very top one. Bam. Now we're on top. Now we're still at a 90-degree right angle or something like that. Click the two side arrows and it'll turn it. Read left to right, top. Now we're going to click 2D or our cutting symbol and we're going to select a tool. If you don't have a tool under your local library already, you go to local, library, and there's nothing here. You'll click this plus sign in the top left hand corner and it'll say new tool or control N. Click it. There's a bunch of tools you can use, a bunch of machines you can use for this software. We're only using a plasma cutter. Put in a description of it, my cutter for some reason, vendor, me, just kidding, razor cut. You don't have to put any of this information in, just put in whatever you want. Cutter, it's a plasma cutter. It reads in inches because we're in the United States. Your nozzle diameter is going to stay at 0.0315, what we got at the house. Kerf width is going to be 0.055 or 55 hundredths of an inch. Accept. Bam. Now you created your plasma cutter. Since I've already had my own, I'm just going to delete that. Delete tool. Yes, delete. I'm going to double click mine. And bam. If you put in all these parameters and click all this geometry and set all your stuff up right, and don't have your tool selected, it will say there is no tool selected and it will reset all of your parameters. Make sure to select your tool first. You got cutting mode, we're going through. Me, 1/8 inch steel, carbon steel. It's going to be 78 inches for me. If it's aluminum, 72 around. Now we're going to select our geometry. And it's pretty smart. It'll know to cut on the inside of these holes, on the outside of the plate. It's a fairly smart software. It's not stupid. It can be, but we won't get there. Now our lead-in sweep angle is going to be 90 degrees. So you want it to pierce the plate straight down. We don't want to sweep in at an angle to pierce the plate. We just want it to drop straight down, pierce, and then start cutting. Our lead-in distance is going to be about half of our smallest cut, which is 0.375, which is like what, 0.187, 125, something like that. We're just gonna do 0.18 just to be safe. You can set out a lead out exit or lead in. I keep both these highlighted unless you're doing something with aluminum or stainless where the dross might rise to the surface when you pierce the plate like a thicker plate. If it tries to lead back out where it let in, where it pierced the plate at, it'll hit that dross and possibly move your plate and mess up the rest of your cuts. So, but that doesn't matter here on carbon steel. You normally won't have that problem. You might incur that problem with aluminum or stainless sometimes. But again, trial and error. I'm going to click OK for now. Click OK. And ta-da! You notice your lead-in distance is where it's going to pierce and lead into the cut and start cutting. And lead out is where it's going to go. When it finishes cutting the circle, it's going to go straight back to where it pierced at, lift up, and go to the next cut. Now we've got our tool path created. Now, if you want to simulate the machine that everything's going to work properly, and you got everything cutting in the right order for some reason, maybe you want certain things to cut out first before the others, you're going to go to Simulate Machine. And you click this play button down here, start the simulation. You can click. This slows down the speed or speeds it up. We're going to slow it down just for reference. We're going to start, speed it up a little bit. And as you can see it moving, showing you the tool path it will follow for your cut. Traveling, pierce, lead in, lead out, so on and so forth. Speed it up real quick, bam. Info, it'll show you the coordinates of the torch head based on the 0 location of where it started, or the bottom left corner. Statistics, it'll show you how long it will take to cut the part, not based on pierce delays or nothing like that. How much travel it will have cutting out the whole part, which is 5 feet. So we'll exit simulation. Now we've got everything ready, and you like it, and you're ready to post it and put on the table. We'll go to post process. Now, the first thing you must do is make sure you have the post processing software, the correct one. Langmuir Controls uses the Fire Control Plasma. This is version 0.16. It's the one I used at the house. We'll click it. If you can't find it, download it. Just look it up. Langmuir Systems has a link to it. Might have to do a little searching. We'll set the name of the profile or the folder or the file to my first cut. And you can set the output to like desktop. That's where I like to put it. Easy place to find it. Doesn't get lost trying to find files in different locations and you can't find it. We're going to set our cut height. Generally 3. You can change it if you want. Again, trial and error. Spring back, it'll touch the plate and spring back a certain height. You can turn that on and off. Pierce delay, the thicker the plate, the longer the pierce. Or if your consumables are worn out, you might have to increase the pierce delay. 1/8 inch plate, 1/2 inch, 3/8 of a, half a second or 3/8 of a second. Pierce height and whatever. Retract height and your torch height control. Let's say your plate is warped and it's wavy and you're afraid the torch might hit like where the plate's bent up or something like that, or it's warped up just a little bit. You can turn this on if your table has it, which we do. It will follow the wave of the plate using a voltage. It'll keep a constant voltage between that torch head and the plate, and it'll keep that distance. This could be an issue if you are doing like pretty close cuts, because if it goes over an open area or even close to an open area where you've cut already, it will shut that torch off and you'll have to restart from where you cut at. And it can be a pain. So sometimes you could turn it on, sometimes you could turn it off. It's all you. Now that we got everything done, everything's set up, we're gonna post it. And next I will create a video on how to open it in the fire controls and operate your table.